All right, everyone. So thank you for coming. Um, let's just make sure that okay. All right. Most important part is up. Um, Thank you for coming. My name's Greg, and this is a version of a talk that I did at Take Communications last week. Um, and I'd like to discuss this with you guys. Um, this particular version of the talk, I'd like to be quite interactive, so please stop me, ask questions if you like, and so on. And let's see what you think. All right, so basically, of course, the title is something that anyone who's ever designed anything can relate to. Because whether you've designed a device, a process, or some way of doing things, there are always these people, always there are some of the people who use them, who come in and ignore your carefully designed, yes, first they'll do this and then they'll do this and so on plan, and they do it their way. So, that is basically what I'm looking at for my research. How does this process really work? The finding a new way to use pre-existing IT artifacts. This is basically a summary of what I'm going to talk about. What I'm looking at are recognizable patterns of information processing that happen in human cognitive systems. And the way I define human cognitive systems, a little different from what you may be used to. And I hope that understanding these patterns of information processing, these mechanisms, can give us some insights into user creativity and more broadly into the interaction of users and the things that we build. So why does this matter? Matters for a number of reasons. I have a couple of examples. One is M-Pesa, which you may or may not have heard of. It's a system that has been deployed. It started out in certain parts of Africa where telecoms companies started allowing people to buy airtime and send it to other people. And they intended that for people who, say, have family who live out in the bush, far from places where you'd be able to buy a phone card. And they put that system in place. A few years later, some researchers went and looked at how people were using their phone and discovered that users had found a way to start using airtime as a proxy for money. And that they were basically using airtime to buy and sell and so on. Eventually, right now it's become the largest, that was taken on by the telecoms companies, and it's now become the largest non-bank finance system in the world, and is being rolled out to different parts of the world, and it's become very empowering for the people who developed it and very profitable for the people who own the networks that it runs on. And then there's Twitter, which started out as a microblogging service aimed at friends and family. You know, if friend is far away, maybe he can tweet and say what he's having for breakfast and so on. And now, well, so what do they have in common? The success of each started with an idea, with an innovation that was had by the end users and not the developers. Twitter's growth, I think, was largely due to the hashtag, which fundamentally changes the way you can use Twitter. Twitter started out as a tool that would help you to follow people. The hashtag allows you to follow ideas and follow topics. It's a sea change. That's what makes it able to be used to organize protests, organize parties, do all kinds of different things. And it wasn't the developers who had that idea. They didn't know what they were building when they were building it. And that happens quite a bit. So here's roughly what I did. I did a series of case studies of creative appropriations of various kinds of IT systems in various kinds of companies in Christchurch and in other parts of New Zealand. And I did what's called a retroductive analysis to identify my mechanisms. And I won't go into the details of the methodology. It's interesting, but I've discovered the hard way that in order to present everything in my project, I'd need a little more time, like an entire day or so. So I have to pick. And so I'll be selective about what I present, but I would like to talk a little bit about the theoretical lenses I'm employed, because this is interesting stuff and it helps to contextualize the final findings. So I'm using dual process theory from cognitive psychology. Dual process theory is basically based on a realization by a number of researchers that the human reasoning system is best conceptualized as being composed of two separate but interdependent and interacting processes or systems. System one is a fast, relatively effortless, automatic system. It's basically associative in nature. Processes in system one are able to run in parallel without interfering with each other or with system two. In practice, what that means is that system one has a very high bandwidth. It can handle a lot of different kinds of stimuli simultaneously without fall off in its performance. It is not conscious. You are not aware of your system one. It is functioning right now. You cannot feel it. You cannot think it. System two is relatively slow. It's effortful. When you apply system two to a stimulus, it feels like work. Its operations are basically rule-based, and they are serial. In other words, only one, system two process tends to work at a time. System two is conscious. When you say I, you're referring to your system two. Now, system two doesn't know about system one, and both system one and system two are emergent from lower level cognitive processes. Some cognitive scientists dislike dual process theory because they feel like it oversimplifies a lot of really complex underlying processes that go on in the mind and the brain. However, dual process theory is a way of understanding two fundamentally different modes of operation within the brain. It doesn't imply that the underlying structures of the brain map to the system one and system two, but these two types of processes do exist. And so let's have a closer look at them. Wait, don't answer this yet. Notice that you were able to stop the calculation when I said don't answer this yet. So you have volitional control over whether or not you answer this question. If you chose to answer the question, if I asked you to do it and you tried, your pupils would dilate, your metabolic rate would rise measurably. You would go through a series of steps that you could describe to me verbally if I asked you to. All right, first you add this to this, and then you carry the one. So you could do that. And it would to some extent be unpleasant. Even if you like math, there is a part of you that would have to sort of grit your teeth and do it. And that is inherent to the system. One of system two is designed to minimize effort, to conserve energy. And so the system defaults to the least effortful way of responding to any stimulus. All right. Okay. Meet system one. Wait, don't do it yet. Anyone not know? No, okay, right, okay. You already knew the answer when I asked the question. The process by which you came to that answer felt more like recognition than doing a calculation. You would not be able to verbally describe to me the process by which you recognize what the answer was. All of those are typical of System 1 responses. Now, understanding the difference between the responses of System 1 and System 2 are important because there are some classes of questions for which System 1 and System 2 will generate different responses to the same stimulus. A guy named Sloman described these as criterion S problems. Like this one. Now, if you're familiar with this at all, you recognize it. It's the famous Miller-Lire illusion. And if you're familiar with it, then you already know that the two horizontal lines are exactly the same length. You know that, don't you? If you didn't know it before, I just told you. And then, even better, what I'll do is I'll put my arm up here, and then I can't get my arm quite up high enough, but you can see they're vertical. They're exactly the same length, right? And now that you know that they're exactly the same length, the top line still looks longer than the bottom line, doesn't it? Yeah. That is the thing. System 1 is always on, and it's always generating stimulus responses. The kinds of spatial calibration that makes you able to estimate the length of lines is part of a System 1 process. And so it's working, so even though you know at a System 2 level, all right, these are the same, they still look different. And understanding that is important because sometimes you do need to process things with System 2, even though a System 1 response is generated. Because sometimes System 1 is very efficient, but sometimes it misses things. Let me give you an example. Now, suppose your life depended on it. How many dots are there, really?
Trick question.
It's not a trick question. Have a look. How many dots are there?
5, 4, 3, 6.
Yes.
Many million.
Yes.
One.
Okay, yes.
1080 times.
Right. No, all of you are acting like, oh yes, I knew that all the time. Ha! Yes. Even I didn't spot it at first, and I wrote the slide. But anyway, no, it's true. And this kind of thing, this is a trivial example of something that happens to us quite a bit, which is that we get these quote-unquote intuitive, they feel like intuitive responses to stimuli that are generated by associative processes in System 1 that are not correct. But most of the time they're close enough to be okay, to be useful. Sometimes they're not. And so sometimes it matters quite a bit. Now, in my research, I'm applying a third level of cognition, distributed cognition. And this is based on work that was done by a guy named Hutchins in '95. In cognitive psychology, we maintain that cognition, thinking, is basically a computational process. And we talk about representations of knowledge, objects, things in the world, and the mental computations that are involved in transforming those representations. Now, both the representations and the calculations that transform them are not necessarily limited to within the individual. I can have a representation of a calculation I need to carry out in my head. I can also write it down on a piece of paper to help with the calculation, or I can put the calculation into a computer, or I can talk to somebody else and the two of us can figure out what the calculation needs to be. All of those things are extending the cognitive system beyond me and into objects and people around me. Now, the fact that distributed cognition essentially says that mental cognitive processes don't necessarily have to stay in the mind doesn't mean that they're saying that groups of people and groups of tools and so on are like brains. They have different architectures and they'll behave differently, but at a suitable level of abstraction, both collectives and groups and individuals have to do the same thing. They make goals, they go after their goals, they solve problems and so on. And so the basic mechanisms will work in the different kinds of systems I contend. And so key points are this. There's system 1, which is automatic and always on. System 2, which is lazy. That's the simple way of saying that it's programmed to minimize effort. Effort minimization bias is the fancy way of saying it. Lazy is the easy way of saying it. System 1 determines a lot of our behavior. If you just think about it, you have this one system that is constantly coming up with a response to every stimulus it gets, and this other system that is trying as hard as it can to do as little work as possible. So the always doing it system does a lot of the work, but the interesting thing is that the conscious system is not aware of the operations of the automatic system. And so we'll talk a little more about how that works. And cognition is not limited to the operations of S1 and S2, but processes and objects outside of the individual also are part of the cognitive process. And so here are the mechanisms of end-user creativity. All right. Jürgen, would you like to just read this slide for us?
No.
You wouldn't? Okay. No, but okay. Should I wait for a while and let you guys read it? Okay. Never mind. I'm not going to do that. But basically, the mechanisms I've identified are a set of logical structures that enact transformations. They take certain inputs and they create certain outputs. So what I'm going to do is I'm going to take a more detailed look at one of the mechanisms, this last one here, the retrospective reframing mechanism, just to show you a little more of what a mechanism is like. And then we'll look at an integrative model and sort of look through what the mechanisms do together as a system. And so retrospective reframing mechanism, its basic function is to write narrative accounts of events to long-term storage. Now, long-term storage could be at the individual level, your memories, your encoded schemas about how things are, and at the distributed cognitive level, it could be anything from written accounts to, historic stuff, whatever. Now, it receives incomplete narrative information about what actually happened. In this case, in this context, we're talking about the creative event, the event where someone discovered a creative way to use a system. And it also receives an abstract script for how the creative process should work from prototypes. Now, it replaces missing information in the narrative account with information from the script. And so this is what it looks like as a logical structure. Now, it starts off with the prototypes. At each level of cognition, system 1, system 2, distributed, I call the prototypes a different thing, and they have different structures. At this system 1 level, we'll be talking about something that's stored neuronally in the brain, some schematic, At the distributed cognitive level, we might be talking about written records, academic, papers that say this is how we discovered such and such a thing, whatever. But basically, the important thing is that the prototypes are inputs to the process. Now, the event data is also an input to the process, but it's just one of the inputs to the process. Event data is always incomplete. And that includes events that you directly experience and events that you hear about. If you hear about how the iPhone was created, you probably won't hear the full story. You won't hear about all of the people who did all of the work, and you probably just hear, some of this and some of that, right? But if you say were to tell someone later about what happened in this room, what you tell them is obviously going to be incomplete. Because even right now, as you listen to me, you look at me, what you're seeing is largely a construction of your brain. You can't see the scene that you're seeing with the kind of detail that you see. Right? What you see is not just coming from your eyes, it's coming from your visual cortex filling in a lot of dots. If you've ever studied visual perception, a lot of that goes on. And so everything that you experience basically is constructed reality.
Does it sort of feed back into itself?
Well, actually, this kind of explains a number of things. So event data along with the prototypes going, and the prototypes essentially are reinforced by what comes out. So it kind of explains a lot of things that we know about in my talk specifically about creativity. We know about the creative process that we know are wrong, but that still remain part of the prototypes that are available in the culture about the creative process. Everybody knows that creativity starts with, some kind of genius who stays alone in his corner and comes up with a great idea. That is absolute nonsense, right? Extensive studies have been done. All of the accounts of scientific discovery and major discoveries and creativity that involve something like that always turn out to be more complicated than that. Steve Jobs created the iPhone. He invented the iPhone. Thomas Edison invented the light bulb. It's never that simple. But that's what gets written to the culture, because people don't get the full story. People don't know about all the different engineers and about the guy who invented one part of the light bulb and then it wouldn't work and then this other guy invented, no, you have to thread the thing at the bottom and so on. People don't know all of those details, and so they fill it in. And they fill it in with their prototypical beliefs about what happens in a creative process. And so what comes out is something that sort of matches their beliefs. And then those beliefs get reinforced again. And so that goes on and on. So even though the scientists know some things about creativity don't match what we normally think, those things that we normally think still survive in the wider culture. And this basically is the mechanism through which that works. Now, this is a model that kind of integrates that list of mechanisms that we looked at before. I'll go very quickly through how the model works. We start with the real world. Now, and I should mention this in explanation is at the individual level. But I'll talk about how each of the mechanisms that I described works at the collective level as well. So you get sensory information from the real world about the state of the world. that is mixed with prototypes, prototypical information by the representation construction mechanism to form a primary representation of the world. Of course, we don't interact directly with the world, we interact with our representations of objects in the world. I cannot interact with this chair because I'm over here and the chair is over there. But because I get sensory information, because my eyes are able to see light that's reflected off the chair, I can know that the chair is there, and I can know that if I do this, I won't fall down because there's a chair here. So I'm interacting with my representation of the world and not the world itself. This is the primary representation that's formed here. Now, most of this stuff you do in a sort of routine manner. You don't, it's not at the automatic level, it's not at the level of system one, totally. If I asked you about what you did this morning when you got up, you could probably describe it to me. You'd be able to say, I brushed my teeth, I had a shower, I got rest, and so on. But it wasn't hard. You weren't working really hard mentally when you were doing that. It's a sort of low power mode of operation that I call the serial associative mechanism, essentially routine. However, at some point, you'll run into a stimulus that requires you to evaluate different options for how you could respond to that stimulus. Now, when you do, that triggers the decoupling mechanism. The coupling mechanism does two things. One, it copies the primary representation to create a new copy of the primary representation, and two, it decouples. It keeps that copy of the primary representation separate from the main copy. So it creates a secondary representation. Now, the reason why that's necessary is to prevent what's called what a guy named Leslie called representation abuse, which is the corruption of the primary representation by simulated ideation activities, essentially losing the ability to tell what's real from what you're imagining. Now, within the secondary representation, a process of simulation occurs, and that process is enabled by the representation transformation mechanism and the attribute substitution mechanism. Now, at some point, you'll come to a possible state of the world that would meet your goal, that would be an adequate response to the stimulus. Call it an idea, for want of a better term. So your idea needs to be copied over to the primary representation. That has to be done because the whole point of the secondary representation is that it doesn't have the keys, basically. You know, it's not going to be able to get you in trouble. You know, if I stand at the top of a building and I imagine that I can, you know, walk on air, I'm not going to step off the top of the building and fall because I'm just imagining it. But if I decide that I want to try out walking on air, then I have to transfer it over to the representation that is able to get my feet moving, so to speak. So it copies from here to here, and then initiates some kind of concrete action to change the state of the real world. Now that's done by what I call the concrete transformation mechanism, and that action that you take will have an effect on the real world. Now the effect may succeed or it may fail. If it succeeds, then fine, you're done, and you can go back to routine operations using the SAM. If it fails, you learn something. You get new information about the real world. Oh, I can't do that. And that goes back down into the primary representation, that's copied again to the secondary representation. And so you get a kind of cycle that works like this. That gets started. And that's an iterative process. It continues until it succeeds or it's terminated. At the same time that that's happening, you're also observing, you're learning about what you're doing. And so there's information going from here back into the primary representation, but it's filtered through the RRM. And so what you get here is a construction. And basically that is how the system works. Now one of the findings of my research is that this corresponds to what is known as the business as usual hypothesis of creativity, which is that there is no such thing as a creative process. Creativity, I mean within the brain. Creativity is a complex outcome, but it emerges from normal, routine mental activity. There isn't some special spot in your brain that lights up when you're being creative. But sometimes it feels that way. Because a lot of this can happen below this line. A lot of it can happen in your non-conscious brain. That's why sometimes you'll go to bed worrying about a problem and you'll wake up the following morning and you'll, aha, this is what. And that's what it feels like, right? It feels like, aha. Because sometimes you're not aware of what's going on here, but you're aware of this one. This line is a conscious line. You think of it as having an idea, your eureka moment, but it's always part of a process. Every time we're able to measure the inputs to the process, we find that creativity is a process. Even though, to some extent, parts of it are not transparent to the people who are actually being creative. So, like I told you, I put this together for a company, and I had a couple of examples that were specific to the things that they do. One of the things that they are interested in is how people respond under pressure to situations that are highly volatile. And so this, well, I won't go into this too deeply, but basically what I was talking about when I was chatting with them is about how deeper and more complex understanding of cognition can feed into the design process. And so here we have this situation where a group of firemen, this is a real thing. It's from some work on fireground commanders that was done by a psychologist named Gary Klein a few years ago. And basically, they were trying to capture the expertise of expert, highly experienced fireground commanders in a way that could enhance training for regular firemen, So instead of having to go through 10 years of experience, making all these mistakes, we can just create a knowledge base, and sit you down and drill it into you, and now you're an expert fireman. Doesn't quite work out, but in the process of trying, we learn a lot. So this group of firemen are in a kitchen, dousing a fire. Everything is under control. Soon after they started hosing down the kitchen, the commander heard himself shout, "Let's get out of here," without realizing why. I love that line. The commander heard himself shout. Seconds after they got out of the kitchen, the floor collapsed and the entire place went up in flames. It turned out that the real fire was under the kitchen floor in the basement, where it couldn't be seen. They'd been in there when the floor collapsed, they would all have died.
So did the commander know about this at all?
Huh?
Did he know about this, or did he just have a sixth sense as such?
He just heard himself shout, "Let's get out of here." Now, afterwards, when he thought it through carefully, he realized his ears were unusually warm and the fire was too quiet. Looking back on it, he realizes that. But at the time, he didn't have time to think about all of that. He just heard himself shout, "Let's get out of here." Now, what that speaks to is, remember I talked about how System 1 has a very high bandwidth, a high capacity for stimulus response. System 1 is capable of analyzing large amounts of stimulus all at the same time, very fast and very efficiently. System 1 is why it's so easy to drive. Remember when you were learning to drive, how hard it was, to concentrate and remember to signal and, oh my God, I'm going to crash. Oh no, oh, okay, and so on and so forth. And now it's a lot easier to drive, and you're able to just move along, and when there is a real crisis, you're able to respond quickly, but in ordinary terms, you can listen to your music and you can chat with your friends and drive, and it's no problem, no big deal. There are two kinds of structures in System 1, knowledge structures. One is called ENB, Encoded Knowledge Base. Yes, I know that knowledge is spelled with a K, but the guy who named this construct is very intelligent, and I'm sure he must have a good reason why he didn't call it EKB instead of ENB. It's called ENB, Encoded Knowledge Base. That's the stuff that you're born with. That's built into the system. And there's another set of structures called TCLI, Tightly Compiled Learned Information. And you learn this gets encoded into System 1 over time. Knowing how to shift down and check your mirrors and so on for other traffic and so on when you're driving, that gets encoded into your TCLI over time. And figuring out that the fire is too quiet and my ears are too warm is something that gets encoded over time into your unconscious system. And your conscious system is too slow and has too little bandwidth to notice all of those things. At least not consciously, right? The System 2 is limited, appears to be limited by the capacity of working memory. And there are well-known limitations to the capabilities of System 2 and how much it can hold in, how many objects it can manipulate at a time and so on. System 1, much more efficient, but simpler.
Would you say that System 1's more subjected to like mode blindness, that sort of thing?
That would be an oversimplification. It's one of the tricky things about dual process theory is that it's very easy to go, okay, he did such and such, so that's a System 1 response, that's a System 2 response. It's not quite as simple as that, because there is no such thing as a System 1 stimulus or a System 2 stimulus. Most kinds of stimuli can be responded to by either system. So don't oversimplify, but there are clear tendencies and things that we can look at. There is another one here. These guys they're talking to fireground commanders. One commander talked about ordering his men off a roof because it had gotten squishy. The fire had undermined the supports of the roof, and the roof was dangerously close to collapse. So they were excited. Yes, this is something important that we can teach the young firemen, so how do you know? And the commander said, you simply have to stand on enough squishy roofs. To a novice, all roofs feel squishy. So you're never going to be able to, and that's the thing. Because when he talks about squishy, he's talking about some things. If you were to talk to a structural engineer about them, about degree of resonance and so on, when you step on the roof and so on, probably something really complicated that you could model. But to him, it just feels squishy because of System 1's high bandwidth. It's able to make some surprisingly subtle and deep inferences from evidence. And we experience that as things like intuition, intuitive guesses, and so on. But the important thing to remember is that, one, it is simple, so sometimes it can be wrong. And two, you have to know what kind of environment you're operating in. Is it a hostile environment? And hostile doesn't mean dangerous, because in the middle of a fire is not a hostile environment, even though it's dangerous. Hostile environments have to do with other actors being in the environment who know that you know the patterns and are able to use that knowledge against you. Like some of the other clients that these folks talk to are policemen. So policemen will often be in dangerous situations where they're facing off against other humans who will be trying to guess what they're thinking and then outthink them. And so there is no simple answer. I'm not giving any simple answers to, how should you design processes or how should you. I'm just saying that understanding better how thinking works can help you to think about, well, what do I want here? And so basically, I think that my work does add a level of explanatory sophistication to how we look at incidents where users find new ways to use IT artifacts. And it also potentially provides a way of addressing some other domains as well. But I did promise that looking at these patterns would give us some interesting insights. So these are a few insights I pulled out. One is that creative appropriation does not usually just happen. There are some theoretical models that say, over time, users, as they become more familiar with the technology, they'll start to use it more creatively and so on and so on. I did not see that happen in any of my cases, and the science suggests that it's very rare that it will happen. And the fancy way of explaining why is to say that the decoupling mechanism has a high threshold for activation. In other words, it's a very cognitively expensive process, and the cognitive system is programmed to minimize effort. So typically, if something can be handled without triggering the decoupling mechanism, it will be. And this is one area in which I think my work has to be viewed very separately as work on other kinds of creativity. Because if you're a creative pianist, your goal is to be the most creative piano player you can be. And so you're going to work at being creative. If you're using Excel, typically, your goal is not going to be the most creative Excel user you can be. Your goal is going to be to use Excel to do something. And it's only when Excel is not doing the something that you want it to do that you're going to actually make the effort to, push yourself to do something creative. Individuals usually cannot fully describe their own creative process because some of it at least happens below the level of their own conscious awareness. The eureka moment is a myth. Even if you suddenly had this brilliant idea, the reason why you were able to suddenly have the brilliant idea is because of your years of training and your background in the problem domain and so on and so forth. Eureka moment just doesn't happen. It's always a process that can be analyzed. And of course, if you have a sophisticated understanding of the underlying cognitive processes and mechanisms, it can help you to facilitate or constrain creativity. And the or constrain is important because a lot of times we think of creativity as a good thing. If I say to someone, you're very creative, they'll take it as a compliment. But creativity is associated with risk, uncertainty, and cost. There are several circumstances in which you don't want to encourage creativity. I wouldn't necessarily want a creative pilot landing my plane. You know? But then if something went wrong with the plane, all of a sudden I might change my mind. Oh yes, now I want creativity, you know, land it without killing me, please, you know. And so I'm not trying to come up with a set of, so to be creative you do this and you do this and you do this. I'm not trying to come up with a list of, you know, ways to be creative like that. I'm saying that if we understand the process better, then we're better able to manage it and work toward the outcomes that we would like to have in this particular context with this particular system. And so that's what my work is working toward. And that's basically it. Thank you very much. Now, what I'd like to ask you to do is ask me the hardest questions you can possibly think of, you know, so that when I face the examiners, I can laugh at them. That's what you want to know. Answer that. No. But seriously though, happy to take any questions or comments.
You talked. I mean, you showed us at the end like one of your models.
Yeah.
And the model itself seems like that's pretty like okay how our brain and how everything works, stuff works. You have 6 other models.
Mm-hmm. Yeah.
How are they different? Or are they describing something completely different or something similar? Because,
okay, I don't know if this will work. Basically, each of the models will describe, for heaven's sake.
That's fine.
Yeah. Each of the models will describe one of these mechanisms, one of the mechanisms on this list. Now, the models themselves will be different, but some of the models are same, different. Like, for instance, this one and this one are both of the same type. How I can say this. Mechanisms are inherently hierarchical. And that's true of complex mechanisms and simple ones. I've found that there are certain basic mechanism types, certain basic types that describe more than one mechanism. And so the RRM and the RCM are are the same type of mechanism. They both take inputs from here and a prototype from here, and then they combine them to form a representation. The RCM creates a primary representation of the world. The RRM creates a representation of the process that you're writing to long-term storage. So they're similar. There are others, like the SAM and the coupling mechanism, that are not subtypes of another type. They're their own thing. So basically, each little diagram that I do to describe a mechanism will describe what it does logically with inputs and what outputs it creates. So there'll be, it varies by mechanism. They won't all look the same. Anything else? Yes.
You mentioned that the eureka moment is sort of a myth, and it's really something that requires knowledge and a lot of study, a lot of work, and so on and so forth. And it seems to me that, from my perspective, the notion of a eureka moment is not to say that you come across something without having the requisite knowledge.
Yeah.
It's the combination of that requisite knowledge that somehow, somewhere along the line, comes to you in a epiphany moment for you, and they all come together. Whereas it doesn't come to you, maybe someone else, or they would have the same, background and knowledge. And so, in that sense, it doesn't seem to me as something that should be debunked as a myth. It's something that really does happen. Sometimes to some people, in some way, for some reason, it's just they come together in the right way, and boom, they wake up or whatever, sleep or whatever else. And so it seems like a very real thing. Why debunk it? Is there a methodical way that you would argue it would be? Well, here it is. It's not eureka. It is because they methodically found their path to creativity or whatnot.
Well, there is a school of thought in creativity research that says basically that you can't investigate the creative process because creativity, ideas, come from are essentially events that cannot be predicted or explained. They're just these little things that happen. They happen at random. You can't tell why or when they're going to happen. Therefore, it doesn't make sense to scientifically study creativity as if it were, I don't know, intelligence or innovation or something else that has logical steps. That is one school of thought. The other school of thought is that creativity is part of a process. It's a complex process. And it's not entirely transparent to the person that's involved in the process. Therefore, you have to be, ironically enough, creative in how you study it. You can't always study creativity by going, all right, now sit down and explain to me your creative process. That you have to know a little more about what's going on than that. And my research supports the second point of view rather than the first. And there are papers that put forward the first point of view. I think the latest consensus in creativity research, though, is that is wrong. And that's based on an incomplete understanding of the creative process. And so that subjective experience of, the idea just coming to me in my model represented by this line here. But even though someone might not be aware of it, and sometimes it is done in a largely conscious fashion, especially if you're talking about an organizational context, this does happen. That's what I'm basically saying. So I'm not saying this doesn't happen. I'm saying it doesn't happen in isolation without this.
Surely the subjective model, or that you're not proposing or supporting, would allow that happens, and maybe because you have all the ingredients for the soup and it just kind of happens, it's not necessarily subjective. And on the other hand, your model, I'm trying to say two things are mutually exclusive. In your model, even though you can put all the pieces and it's complex, so you can't really pinpoint every single piece, there's a notion of when things kind of come together, there's a randomness that maybe just kind of comes out right in that statistical sense, right? And so those two things seem to be talking about the same point, rather than saying they're mutually exclusive entirely. So throw one out if you go for the other. Seems like
they're not completely mutually exclusive, but I have read papers that essentially say you can't explain the creative process. It's just a mystery, and they've done their experiments that show, well, this person just had an epiphany, therefore. But other research shows that, no, it's not quite like that. There are these underlying things, and this person was coming closer and closer to a solution to the problem, even though they weren't aware of it. They thought they were guessing randomly, but when you analyze their guesses, you realize that there was a logical process going on subconsciously that they were not consciously aware of. And so basically they're two different, people in the two different camps disagree. And this camp, the camp I'm in, is winning the argument right now. So naturally I want to stay in the camp that's winning the argument. It sucks to lose the argument. Yeah.
generally, if you have two systems and one is more being used in the S1 system and one more triggers the S2 system, would you name that system that you can run in the S1 a better system? Like if you imagine like Excel and like two different versions, and one I can use more in the S1 system, and one I have to think a lot about it and have to trigger my S2. Would you name that one better than the other one?
It depends. It absolutely depends. This is something we talked about yesterday. If you have a situation where you have to deal with a lot of information and make decisions, you certainly want to lean as heavily on S1 as possible. If you have another situation where you need to be really accurate, where you know being really analytical and correct is really important, then you want to rely more on S2. And so it depends on the context in which you're working. For some contexts, you want to make things really efficient and you won't care so much about the occasional loss of strict accuracy. In other systems, you won't mind that is really hard work to use it, but you just want every decision you make to be the best one possible. And so in one time you'd want to lean on S1, one time you'd want to lean on S2. Depends on the context.
So the controversial question is, making things easier to use, you say, is not always a good thing? Is that so imagine you had like a button to repair your computer and you just have to click it and everything will be fine. And you just click and fine. Whereas you want this more precision and like so
think of the argument between Linux users and Mac users. Which is better? Right? Yeah. You're never going to get a final answer on that.
Yeah.
But the underlying design grammars are very different. Mac is okay. Stuff the users. I'm going to put things together in the way that they should be, and then everything will just work. And some people like that. I don't care about how computers work. I just want the computer to work the way I want it to work. Other people will prefer Linux, which goes like, it's your computer. You should be able to configure it how you want. If you want, you can, redo the kernel and, compile it and, you can do anything. It's your computer. One is more complex. One has a steeper learning curve. One is more flexible. One is a lot harder to configure to your needs, but it might be easier to use out of the box. It's not that there's a right or wrong answer. It's that you have to decide what kind of system you want to make, and you have to understand how people are going to use it, how they're going to want to use it, what kind of users they are, that sort of thing. So I don't think my work lends itself to this is right and this is wrong. I think it lends itself more to these are some things we can think about when we're designing or when we're deciding how to use a particular system.
Making it as easy as possible is not always the correct answer. That's
obviously not.
Yeah.
Obviously not.
So this is what you're saying.
And there are some situations in which you want things to force you to think things through. This is a big problem I have with some kinds of analytical software, where you're doing complex quantitative analysis, and they sell themselves for ease of use. It's easy to use our system. You just do this on the screen and click this button. And yes, what that means is that you're making all these assumptions underlying my calculations and not giving me a chance to review and tweak those assumptions. That's BS, but it's easier to use. So is it better or not?
So you said the Eureka moment. So that Does that hold true for cooperative situations?
Generally speaking, I'll tell this guy Kevin Dunbar. He's a psychologist. One of the things he studied is scientific creativity, and once he was, this happened many times, but he relayed one instance in his papers. He was in a meeting with a lab meeting with a team of scientists, and they developed a new construct. And this one had the idea, but it wasn't so good, and that one interrupted him, and so on and so forth and so forth. Right after the lab meeting, he interviewed the people who were involved, and they did not remember accurately what had happened during the meeting in order to come up with a new concept. The only reason why he knew exactly what had happened was because he was videotaping the actual meeting. But right afterwards, he talks to the people involved, and they didn't remember it accurately either. Therefore, I contend that even in collaborative, collective situations where you'd think most of the communication is happening at a conscious level because people are talking to each other and so on, even then, a lot of what is going on happens at a subconscious level, where the communication mechanisms and the messages and information that are being transferred not totally visible to the people who are actually involved. And so it's not the same thing as it happening in the brain, but it's the same general mechanism that's at work.
So in the same way, for a single person, then you think that the region moment doesn't happen.
Right. It can subjectively happen, but often the way the group would describe it, oh, we all just suddenly had this idea. It's not really like that. It's more complicated than that. Yeah.
Are you saying that that certain system 2 processes would transition to system 1 processes like the fireman, using the squishy floors and building up, in a sense, a sort of intuition for squishiness, and that becomes for that fireman a system 1 kind of process?
Yes, that's a very simple but accurate way of putting it. The actual process, I'm sure, could fill several books of people with different opinions arguing with each other. But basically, that's what happens. For example, let me tell you a surprising one. You see this illusion here. This illusion does not work for people who did not grow up in cities. If people grow up in, like people who grow up in the jungles and the bush and so on, if you show them this illusion, they will not see it. The mental calibrations that we make that cause us to see one line as being longer than the other are something that are part of TCLI and not E and B. And we probably, that's one of the areas of very active research, figuring out what kinds of things are learned and what kinds of things are actually built into the hardware. And so there's a lot of stuff that you think is just part of what you know that is learned, tightly compiled, learned, and has become part of your subconscious knowledge base.
An example of this is like kids. You see, like when you have child or kids, they see like people far away or on a tower. They think that's like small people, and when we grow up, we in this environment, we know, okay, that's perspective, so it means it's just far away.
Right.
This is another example you can still see here when you ask kids. They think it's small.
Yeah.
In your research, did you make much consideration about the impact of emotional sort of values and the creative drive, and even in the S1 and S2 processes? Because from what I know, or whatever, Emotions do play a massive part in your ability to, even have that eureka moment. So, yeah, do you make any sort of suggestions towards that?
Yes, actually. Of course, this is a very oversimplified way of putting it, but the emotion and motivation and so on impacts on my model right here. This thing, your cognitive mechanisms, your cognitive system hates this. You have to allocate a lot of memory to make a copy of the representation, and the simulation process is very expensive and so on. This is not something that you would normally do. And what provides the power, for want of a better word, to this mechanism, to this decoupling process, is that motivation. And the motivation comes in different ways and it works in different ways. And so that is basically where in this I would put considerations of things like emotion and creative drive and that sort of thing.
It's like, I think with one of your other slides you say something about it being a blocker as well as, or maybe not emotion, but you mentioned something else that could be proactive, or it could be a blocking mechanism. So this is kind of the same thing, really. If you're not feeling happy or whatever, you're probably less inclined to come up, be creative in general. You'd probably rather rely on your S1 process.
That's an oversimplification, though. In one study that I looked at, people who were unhappy with their jobs tended to be more creative. Because think about it, if you're really unhappy with how the system works, you might feel driven to find a new way to make it work. And so what I'm saying is, I'm not disagreeing with you, but I'm saying it's really risky to sort of make some kinds of conflation. So if you're happy, you'll be creative. If you're not happy, you won't be creative. It's more complicated than that, because the drive can come from different kinds of emotions. But the drive does have to be there. Yes.
Somewhat related. Like how do bodily processes like adrenaline affect where you're thinking, whether it's conscious, subconscious, and the speed of that thinking? Like if you've got lots of adrenaline, does it drive you through using S1 more than S2? I don't know the answer to that question. No, as in no for certain. B, I think in general, it's risky. Again, it's risky to make blanket generalizations about if you're more excited, you're more likely to use so on and so forth. It depends on the situation, the context, and it does depend to some extent on individual differences as well. There are strong individual differences in people in terms of their likelihood of using system 2 to generate a response rather than system 1. So there are some people who wouldn't have gotten fooled by this at all. Who would instantly have seen before. And I know one of them, that rotten bastard. What's his name again?
Sam?
Michael Myers.
Oh.
Michael Myers, Professor Michael Myers of the University of Auckland. He's the one who actually pointed this out to me, because I'd done it and it was like 3 dots, and I go to Auckland and I'm like, and so this is so yes, and this is system 1, blah, 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 blah. And he just said the answer is 4. Damn, he's right. Yeah. So then I had to pretend that didn't come as a shock, but it's true. But the fact of the matter is they have one of the measures that they've associated with this is something called conscientiousness, but it's not a good measure of it. There are better, more specific measures for this, but
when you're faced with a stimulus like this, do you just accept the system one primed response, or do you look at it and consciously focus? And there are tests for that, and people do show stable differences on those tests.
Do you think it might be almost slightly dangerous being able to, do that? Because, like if you sit down long enough, you could be like, well, actually there's only one dot, or the one dots as such.
Yeah.
Or you could
Or
be
there
like,
are millions of
there's
dots.
millions, or so.
Yeah, it all depends. It all depends. In some cases, doing that will sink you into the paralysis of analysis, and you'll spend forever on a problem that doesn't deserve that much time. In other cases, it might give you an advantage. If you're working in the financial markets and you figure out a better way of predicting what the market is going to do than your competitors, you can beat them and make more money. So it all depends on what domain you're working in.
Very good. Another big hand.
Thank you for coming.